All right, this problem says a ship is 45 miles east and 30 miles south of port. That should say of, a port. The captain wants to sail directly to the port. Bad writing here. What bearing should be taken? All right, so let's just draw a picture first. A ship is, so let's say the ship is right here, and we're saying the ship is 45 miles east. So let's just say east from here, 45 miles, so 45 miles this way, and it is, ooh, that should be the other way, right? Because it's east of the port. So let's go the other way. So 45 miles this way. And it is 30 miles south of some port. So let's say it's right there. So let's call this the port. Let's say this is the port. And we'll say this little spot is the ship. So a ship is 45 miles east of a port and 30 miles south of the port. So here's 30 right there. It says the captain wants to sail directly to the port. What bearing should be taken? So what we're trying to do here is figure out, here's the ship, and we want to know what direction do I need to go in to go sail directly towards the port, which would be right here, right? So we want to know what bearing should be taken. So how do we figure that out? So what bearing should be taken? Well, in order to find the bearing, we're going to need some sort of theta. We're going to need some sort of angle. So it makes sense that since we have a right triangle here, right, right triangle, and we don't know one of these thetas, one of these angles, let's say we're trying to find this theta right there, we could find that, right? Because we could use, again, we could use SOHCAHTOA, and we can use an inverse function to figure out what theta is, right? So if we look at this, we would use tangent, because I'm trying to figure out, I want to know what theta is, right? I know the opposite of theta, and I know the adjacent of theta. So opposite and adjacent, we're going to have to use tangent. We're going to say the tangent of theta, which we don't know what is equal to the opposite, which is 30, divided by the adjacent, which is 45. So if I want to find theta, I can take an inverse, right? We talked about inverses before, and we specifically talked about inverses on the unit circle, right? This is a case where we would just go ahead and use like a calculator and figure out this. We have an equation, and I want to solve for theta, right? How do I get theta by itself? I'm going to take the inverse tangent, so tangent inverse of both sides of this equation, right? I'm going to take tan inverse both on the left and the right. Whenever I take an inverse tangent of a tangent theta, that's going to reverse what tangent does. It's going to cancel out that tangent, and this is just going to equal theta. It's kind of in the same way. It's like saying if I have x and I and I square it, and then immediately after I take the inverse, which is a square root, well then that's just going to undo itself. That's just going to equal x, right? So in the same way, if I have tangent theta right there, and then immediately after I say the inverse tangent, well that's how you solve for it. That's how I get theta by itself. On the right hand side, I have inverse tangent of 30 over 45. So here's like a slope, 30 over 45, and we have to say, well, what is the angle that goes with that slope? So we're going to ask our calculator, and we're going to say inverse tangent of 30 over 45. 30 over 45, and that is about 33.6 We'll just round to the nearest tenth. So theta is approximately 33.7. 33.7 degrees. Now that's not the bearing, right? So I'm going to update my picture, and I'm going to say that this is 33.7 degrees right there, but that's not the bearing, right? So we need to figure out how we can translate this to a bearing. Remember, a bearing has like three parts. We're first going to say north or south. Let's reference north or south here, and then let's rotate east or west. So in this problem, what do we do, right? Our direction is, over here. We're going in that direction. I would reference north here. So I would say, let's just reference north as our starting position. And so let's say north, and let's just rotate in the, if I start north, then I'm going to have to rotate west to get to the angle, which is the bearing that the captain of the ship is taking to the port, right? So then I'd have to figure out, okay, if I do it this way, I'm going to say, north, and then I'm going to rotate west. I'm going to go towards the west. So I'm going to say west over here. But how much in the west direction? How much is this, right? Well, I know that this interior angle is 33.7, right? And that has to be the complement of 90, because that's 90 degrees from here to here. So if we take the complement, that would be, let's see, that'd be 56, be 56.3 degrees, right? So then the bearing would be north, 56.3 degrees west. These are equivalent. The standard angle of 33.7 degrees is equivalent to a bearing of north, 56.3 west.